In this video, we're going to talk about the standard normal distribution, sometimes affectionately referred to as the Z distribution. We'll see why eventually. And in the previous video, we discussed that we can use the empirical rule to find probabilities associated with normal distributions. However, there's limitations to that because the empirical rule really only gives us information 1, 2, 3 standard deviations away from any given mean. And so we are going to discover then how to find area under any normal distribution, not necessarily at discrete marks associated with the empirical rule. So this is with the standard normal distribution. And I often call it the Z distribution. And it's standard because it has properties that its mean is 0, and standard deviation is 1. Very, very nice values for a normal distribution. This particular distribution is very well understood. Right, we mentioned that the total area is a 1 because it's a probability density function. And therefore, under this standardized version of a normal distribution, these areas are well defined and we know them very well. So well that we have a table that will give us the area for just about any region we want under this curve. So for any variable that is normally distributed. So we will be using this standard normal table, I sometimes call it the Z table, to find area / probabilities within the standard normal distribution. I'm going to show you this table now. On our Canvas site, under undated assignments, it's not really an assignment, but there is where you can find statistical tables. This is the Z table, and other tables will eventually show up in this little docket, but right now this is all we've got cooking for us. So the Z table, and I am downloading it, and this is what it looks like. I'm actually going to download it so it comes out a little crisper. So here is this table. It has 2 pages, and we'll discuss what's on these 2 pages. But you'll see there's a whole lot of numbers. And I'll show you how to read it. That's the purpose of this video today, is show you how to use this table. And basically what we've got here are Z values on the left. And there's some precision about them along the columns, and we'll talk about that. But basically the way this table works is you input a Z value, and these numbers all up in the table here are probabilities to the left of those values, to the left. So I'm going to write that down, and we're going to do a lot of examples to illustrate how we use this table. So this video is dedicated to introducing this standard normal distribution and how to find probabilities associated with it via the Z table or standard normal table. And that table works by providing the area to the left of a Z value. And because this is the standard normal distribution, these Z values are interpreted as standard deviations. For instance, a Z value of a 1 is 1 standard deviation above the mean. That would be right there. A Z value of -1 would be 1 standard deviation below the mean, which would be right there. negative 2.4, that would be 2.4 standard deviations below the mean. So that negative sign does have significance, and that would be right around there. Now these first two little bullets, we could find probabilities related to one standard deviation above and below the mean. We could find those with the empirical rule properties, but we're going to instead use the table today to find probabilities. Okay, I've got several examples lined up here. For each of them, we're going to find the solution, but I also think it's incredibly valuable to be able to represent these questions graphically. So for each of them, I'm going to draw a normal curve. I'm always going to put 0 in the middle because it's the standard normal called z. And I want to represent this value positive 1.52 and one tick mark to 1.5. 1.52 would be right around there. And I want to represent the region, the desired area. Remember, this says probability that z is less than 1.52. So I'm going to shade to the left here. Awesome. Just looking at this image, I can tell that more than half is shaded, right? So our solution definitely is going to be larger than 0.5. Okay, so equals. We're just going to go to our z table to find this out. Here we go. So the way this table works is I want to find 1.5 in this first column. Now this is where there's two pages here. This first page is dedicated to negative numbers, negative z values, so those are below the mean. So I need to go to the other page to find positive 1.5. That's great. Now I need the second decimal place to be a 2. Where do I find that? That is along the columns. Notice the columns here say 0.00, 0.01, 0.02. That's where we want to be for this question. So the rows here, this gives you the ones digit and the tenths decimal place. The columns provide the hundredths decimal place. And I know which row and which column I want to find, and so that is our solution. 0.9357. And maybe I'll even represent that in our image over here, 0.9357. Awesome. Let's look at part B. Part A and part B look very similar, but there is a distinct difference. Here we have a greater than symbol, but it's got the same z value. So I don't need to go to the table again. If I want to represent this with an area, with a shaded region, this would be this green shaded region to the right of 1.52. Because we know that the total area under this curve is a 1, and we know the area to the left of what we actually want is 0.9357. Well, that's the region we don't want. So this is using complements. We're taking the complement of our previous answer. So here, our solution is 0.0643. I'll represent that in our image up here. So remember, our z table only gives us area to the left. If you look at the imagery on this table, there's a little image that almost reminds you of that fact. So anytime there is a greater than type of question, you'll have to do a 1 minus sort of procedure with a value from the standard normal table. Let's look at part C. This, I better draw a picture. This question, notice it has a compound inequality. This is a region that's not bounded by the left side or the right side. It's an in-betweener. And I want to put a tick mark over here for negative 2.42. It's kind of far away from 0. But 0.8, that's not that far from 0. 0.8. And that is the region that I would like to find. It's in between those two tick marks that we just made. So now that we've got this region visually represented in front of us, how are we going to determine this with the z table? Okay, here's the idea. We've got two z values. We got to look them both up. I'm going to look up the bigger one, 0.8 first. Doesn't really matter, but it makes sense to do the 0.8 first. Because check it out. If I do 0.8 and find the area to the left of that, it's going to give me a value. And I want most of it. But there is a region I do not want. I do not want the area to the left of negative 2.42. So I would look up this next z value and then subtract the two corresponding probabilities. Let's go to our table. I'm going to go to positive 0.8. So it's going to be 0.8. Now, there is the second decimal place. It's 0.80. So I just need to utilize this probability, 0.7881, 0.80. And I want most of that value, but I want to subtract the area to the left of negative 2.42. So I'm going to go up to the negative side, negative 2.4, and then the column that says 2 is right there. So I found the row and the column that I need. I have now two probabilities that I need to write down, and I'm going to subtract the smaller one from the larger one. Here we go. So the larger probability, 0.7881, that was the area to the left of 0.8, but that's too much. I need to subtract the area to the left of negative 2.42. And as you can see, that is a pretty small area. I think it was 0.0078. So we're subtracting the two probabilities from each other to arrive at 0.7803. All right, let's do one more. Notice in this question, we don't have a less than or a greater than sign. So if I was to represent this with a normal distribution, 0 in the middle, standard z, got it. If I want to represent this on this image, I would have tick mark at 2, and I would need to draw a region. Ooh, but but there is no region to color in because this says exactly 2. Not greater than, not less than. So remember in the previous video, we need to consider continuous variables over an interval. So the answer here is 0. Let's do some more examples, but this time I like to call these working backwards type of problems. And it's only backwards because it's not the first way we were introduced to this table, but it's very valuable in our future statistical processes to be able to go both ways. So in this case, notice with part A, we were actually given the probability, 0.1151. So we're not finding probability. What we are finding is the x value, or actually might even better call it the z value. But to keep notation kind of clean, I'm using x. We're trying to find the value such that the area to its left is 0.1151. Again, I'm going to use pictures to help guide me. So with these normal distributions, because it's the standard normal, 0, middle, and we've got the less than symbol here. Z is less than what? That gets us 0.11. So 0.11 in the left tail is going to be, a pretty small region, right? 0.11, something like that. We are essentially trying to find the tick mark right here, that blue tick mark. We want to find the value that would go on that axis such that to the left of it would be the area that is known, 0.1151. This is working backwards. We're going to use the table, but we're going to look inside the body of the table for 0.1151. Let's roll. I've got my table, and we don't know the z value, so we're not going to look on the left side and we're not going to look on the top yet. I'm looking in the body, this whole mess, for 0.1151. And it's not completely aimless or hopeless because these numbers are increasing. So sometimes it takes a minute to find it, but I believe I have found 0.1151, which is right there. Now that I have identified that location in the table, what is the corresponding z value? Well, this is in the row that says negative 1.2. Negative 1.2. And it's in the first column, so I know that first column corresponds to the second decimal point, being a 0. So the corresponding tick mark would be negative 1.20. Let's write some of that down. Our answer is negative 1.20. I don't need to write that 0, but that is our answer for x, negative 1.2. And just for some notes for you, for your future, what we essentially just did there was we look in the body of the z-table. We looked for 0.1151 and then identified the corresponding z value, which was in blue, negative 1.2. Awesome. Let's do that again now in part B. I'm going to draw a picture again, but I want to try to guide our answer a little bit. With the first problem here, since this probability was so small and we know it was contained in the left tail, we could have anticipated the answer being negative. Because what's the area to the left of 0? It's a half, right? So we know it had to be less. 0.11 is less than half, so it's got to be over here, negative. But here in part B, this has 0.74. 0.74. And it's also pointing to the left. So we need a fair portion of the left tail shaded. We need the entire left tail shaded. But we need this to go all the way to 0.74. 0.74 is what that red region is representing. And again, we want to find this tick mark in blue. But this time, can we expect, is the z value going to be negative? No, it should be positive. Look, it's to the right of 0. Because this area is greater than 0.5 in the left, but it starts out in the left tail, so it has to cross this axis where 0 lies. Okay, but otherwise, we have the same process as what we did in part A. But instead of looking for 0.11, we're going to look for 0.74. Let's go take a gander. Now, I know I need to be on the positive side. I can look all day here for 0.74. I'm not going to find it because I'm on the negative side. So I got to scroll down, and I'm looking in the body of this table for 0.74. And I'm getting close. This time it does not appear that I'm going to find 0.74 exactly in the body of this table. However, what you want to do here is find the two closest values. The way to do that is this one on the right is a little bit larger than 0.74, and this one on the left is a little bit less. So these are the two closest values to 0.74. Which one is closer? The left or the right? I believe it's the one on the left. Now that we've identified the closest probability to 0.74 in this table, let's see that it is in row, the row that says 0.6, and in the column that says 0.04. Our z value, our x I should say, is positive, 0.64. Let's write that down. X is positive 0.64. 0.64. Cool. So the same process occurred here with A and B, but a distinguishing feature here is we wanted to find 0.74 as close as possible, AC, AP, in the body of the z-table. And then identify the corresponding tick mark value, working backwards. Pretty fun. part C is even funner. Let's roll. In part C, we want to find the x value, just like what we've been doing, such that the probability to its left is 1.65. How are we going to do this? Well, you might be jumping to your z table. However, let's remember, what is the largest a probability can ever be? Well, we know that a probability at its smallest is 0, and at its largest is 1. And this is asking for the x value that makes the probability of 1.65. That can never happen. Therefore, there is no solution here. No solution. There is no value of x that would make this a true statement. Pretty cool, huh? Got myself more space here. Let's look at part D and what is different with this question. Well, notice that the inequality is the greater than symbol. And so in our standard normal z distribution, we're going to think about an area that is shaded to the right. The area is quite small, 0.025. So that's going to be in the right tail in a fairly small shaded region here in red. That is 0.025. And again, just like in the previous questions, we need to find this tick mark. We can guess, is that going to be a positive or a negative z value? It's definitely going to be positive. When we go to the table, the z table, to figure out this answer, what we're going to do is actually not look up 0.025. What we want to look up is its complement. Remember, the table only works with left-sided areas. So I want to consider not the area in the right tail, but the area in the left tail, which is 0.975. So that's the value that we want to look up in the body of the table and then find the corresponding tick mark. So let's go to the table. We'll go to the positive side to find our solution. Okay, I'm on the positive side, and I want to find 0.975. I believe I have identified it on the dot. So it is in the row 1.9 and in the column that says 0.06. 1.96 is our solution. Let's type that in. X equals 1.96. 1.96. Awesome. We end up utilizing right-sided areas or probabilities very often in our course, so much that even this notation can become quite cumbersome. And so we're going to introduce this new notation. It's called z sub alpha. And this is the z value or z score with area alpha to its right. To its right. And that's essentially what we kind of just did here. Another way that we could have represented this previous work would have been as z.025. That was the area in the right tail, and we found the corresponding value, the tick mark, 1.96. So we know what this notation is asking and how to figure it out. We just will have to get accustomed to this new way of writing it. Let's try these two questions here. So both of these are referring to small areas in the right tail. We might be able to do them both in one fell swoop here. So 0.01 and 0.05. I will represent 0.05 with pink shaded in, and the color coding will help. So 0.05. And 0.01, well, that's a smaller area. So that's going to be even smaller here. I'll do blue. Oh no, that's green. That's okay. 0.01. So in both of these questions, we are going to find the tick mark that defines that pink region and the tick mark that defines that green region. We can see, based on the image, the tick mark associated with the green area, this one's going to be a little bigger, isn't it? Because it's further in the tail. Okay, when we go to the table to figure these out, I am not going to look up 0.05 and I'm not going to look up 0.01. I'm going to look up 0.95 and 0.99, because those are the complements, those are the areas to the left of pink area and green area. So let's go look them up. We're going to get these both done in one fell swoop. Okay, looking up for 0.99. I see a lot of 0.99 flying around, but I want to get as close as possible. And I believe I found 0.9901, 0.9898. So the one on the right here is just a hair closer. So I have found its z value at 2.33. Awesome. Now I want to look up 0.95. Where are you? I'm getting close, I'm getting close. I think I found it. Again, a little above, a little below, 0.95. And actually it's a tie. These two tick marks here are equally as good. So I would consider either one of those correct. Let's write those down. So we've got 2.33 and 1.64, or 1.65 is also acceptable. So this one is 2.33. We know it's a little bigger, right? 2.33. And this one, if this was a homework or a test question, either of these would be considered acceptable solutions. And over here on my graph, I'm just going to write one of them so it doesn't get too crowded. Okay, I've only got a couple more questions for you, and I promise that is it. Let's find the 10th percentile of z and the upper 10th percentile of z. Okay. These questions are pretty similar, but remember what percentile refers to. For instance, if you scored in the 10th percentile, then you scored better than 10% of other people. So that is referring to this area as being 0.10. And just like earlier, we would want to find the tick mark that corresponds right there. Let's contrast that with the upper 10th percentile. If you scored in the upper 10th percentile, you scored really good. Only 10% of people did better than you. You did better than 90% of people. Now, because of symmetry, right, this graph is symmetric about the center. So we know it's a mirror image along right there. And we can find out both of these answers in one fell swoop, because whatever value we get for one of them, like this one over here will be a positive z value, the other one will just be the negative of it. So this will actually work out pretty quickly. But this is another example of working backwards, right? Because we were given the area using the verbiage of percentile, and we're finding the tick mark. So just like a couple minutes ago, we're going to go to the body of the table and look up 0.10. Looking at 0.10 is going to be easier because that is in the left tail already, just like the way the table is set up. Here we go. And 0.10, that's going to be in the left tail, so I am on the negative side here, and I am looking for 0.10. Where are you? And I'm getting close. I'm getting close. I believe I've found the probability here. It's a little bit bigger. This one's a little smaller, but this one is just a smidgen closer. So I want the tick mark value in this row that says negative 1.2, and in this column that says 0.08. So our answer is negative 1.28 for our first answer. Negative 1.28. And over here, this would make it positive 1.28. And I guess to be super complete, I will write it over here. 1.28. Ooh, and because the upper 10th percentile was an area to the right, I could have written this as such. 10% in the right tail corresponds to a tick mark of 1.28. Okay, so this video, a lot of examples on how to use the standard normal z table. We're going to use that a lot. In the next video, we will look at applications. So we want a strong understanding of how to use this table, so that way when we layer new concepts on top of it, we've got a strong foundation. See ya.